Okay, so this is a basic example of compounded interest. I'm looking at 5% interest rate on $100. So this is an example of how you would look at it using different um, interest rates and compounding periods. So in the first period, we're just going to do simple interest, which is we're going to use the future value formula, which could be found in their financial FV. That's all you need to do is find financial FV. And anyway, when we plug in FV equals FV, 5% for one period, we're going to put $100 in, so we're going to put the negative sign. Always remember to put the percent. We're going to come up with a rate of 5. Now, if we want to look at it if we compound over 2 periods, well then it's simple. We're just going to divide the 5% by 2 and multiply the periods by 2. And you're going to get a slightly higher rate, which is 5.0625. Now, the reason why it's higher, you're getting another 6.25 cents on $100, is because you are paying the interest once in 6 months, and then in the second period you're paying the interest plus the interest on the interest, which is after you paid the first period, you're going to get half of the 5%, and then you're going to pay interest on the original 100 plus that a little bit of extra interest, which is another 250, and that's going to come out to 5.0625%. Now here, we're going to look at 4 periods. I wrote that incorrectly. So 4 periods now, it's simple now. You just got to divide by 4 and multiply by 4. And notice it goes up just slightly, because now you're doing it every quarter. You're paying yourself in a quarter, and in the following quarter you're earning interest on the original amount plus that little bit of interest. Then the original amount plus that little bit of interest, and you do that 4 times. Now notice when I go annually and divide by 12, multiply by 12, let me make this a little wider, I'm going to get even just a little bit more, 5 and 11. Now I'm just picking up a couple more pennies. But it adds up. If you have millions and millions or billions of dollars, compounding adds up. Now if I do a daily compounding, notice now it just goes up by an additional 1 penny. Because even though I'm compounding daily, my additional interest is just growing ever so slightly. And just for the sake of illustration, I'm going to compound 10,000 times. Assuming I pay myself every 10,000 times a year. But I have to divide my interest rate by 10,000 times, and now I go up just a fraction because I'm just getting little slivers. And then finally, and this is really important, if you put the exponent formula in, E equals exponent, and add the rate, you're going to get continuous compounding. And continuous compounding, it means it's almost like a mathematical construct. We're using Euler's number, but what happens now is we are compounding continuously, and we use that for a lot of financial models. So if we do it that way, we're going to get 5.127109. That's about as much as you can compound it. So you start to see how the compounding of interest kind of adds up, but only up to a point. We started at 5 if we did a simple compounding of 5%, but if we continuously compound, we're getting up to 5.127. So we just grow ever so slightly. This is a good example. Definitely you want to learn about the exponent, because the exponent gives us the continuous compounding number, so that's important to remember that. I think that about covers it, but that's something I wanted to do for my classes and for the stuff that I'm studying, so that you could understand how compounding works. Thank you.